This question is application type in the wave. Uh, in the waves, you are creating transverse waves, which means the transverse waves like this using your rope. You have a rope and you are shaking it, your hand from side to side like this. Is like a horizontal transverse wave you are making without changing the distance that your hand moves. So you are not changing the distance as you are fixing your hand and moving it side by side to side, and to create the transverse wave. What is the question? You begin to shake it faster and faster. What happens to the amplitude? If you shake faster and faster, what happens to the amplitude? I can draw like this. Okay. Now you are shaking your hands side by side, and you don't change the length, the distance that you fix your hand and moving up and down or side by side, and you are not changing its length, the distance, which means you are not changing the maximum height from the equilibrium position. So what is amplitude? The maximum displacement of the particle, or the maximum displacement of the wave, the height of the wave from the mean position. The mean position is the line, the middle line. Okay, from here the maximum displacement on the top, at the bottom, this the height of the wave from the middle is the amplitude. It does not change as you are not changing the distance that your hands move. So what is the answer? The number one answer: amplitude remains remains the same remains the same. Okay, next question: wavelength. Now you are moving it faster and faster, which means you are trying to increase the number of waves, as you are increasing the number of waves. You can notice the length of one wave decreases, which means the wavelength decreases. You can say the wavelength lambda decreases. And the next, frequency. It is opposite of wavelength, so the frequency increases because you are increasing the number of uh, waves. And the period is inversely proportional to the time period, right? F is equal to 1 over time period, or the time period is equal to 1 over frequency. It is inversely proportional. If the frequency increases, time period decreases. Okay, now the last question, V. What happened to the velocity of the wave? It remains it remains the same. It remains the same because the wave velocity in a rope depends on the tension and the mass per unit length, not on how fast you shake the rope. So it just depends on the velocity, it depends on the tension of the rope and mass per unit length of the rope. So it doesn't change, it doesn't matter that you increase and decrease the number of waves, is not a problem. So the velocity of the wave remains the same.